As we learnt, matter is anything that has mass and occupies space. Every substance is made of matter and has unique properties. We can classify properties as physical and chemical properties. Let's learn about them. We have with us a rubber ball. Let's see how we can describe it. By looking at and feeling the ball, we can see that the ball is a solid. It is round and yellow in color. It smells like rubber and it bounces. Now, let's observe this block of sulfur. We can say that sulfur is a yellow solid crystal and has a strong odor. What we saw are the physical properties of a rubber ball and sulfur. These properties can be easily seen or felt. Thus, we can say that physical properties are those properties that can be measured or observed without changing the identity or the composition of the substance. Color, length, mass, area, texture, elasticity, odor, melting point, and boiling point are examples of physical properties. Physical properties help us describe a substance. However, the description is not sufficient to identify a substance. For example, saying that sulfur is something that is yellow and solid and has a strong odor is not enough, because there can be many solids that may have the same properties, including our yellow rubber ball. Hence, it is necessary to also know the chemical properties of a substance to identify it correctly. The chemical properties of a substance can be observed when a substance undergoes a chemical change. Flammability, reactivity to an acid, and reactivity to water are examples of chemical properties. For example, if we burn sulfur, it produces a blue clear flame. Thus, the blue clear flame is a result of chemical property. When performing a chemical experiment, scientists study the properties of substances. This involves measuring the quantitative properties of a substance. A quantitative measurement comprises a numerical value and a unit. For example, this block of sulfur weighs 200 grams. Here, 200 is the number and grams is the unit. The units of measurement are derived from two systems, the English system and the metric system. The English system included units such as yard, foot, inches, miles, and gallons, to name a few. However, there was no uniformity in the conversion of one unit to another. In 1791, the French Academy of Science introduced the metric system. Under the metric system, the units of physical quantities relate to each other as multiples of power of 10. For example, 1 kilometer equals 10 to the power of 3 meters. This system was found to be convenient and hence was used worldwide. In 1960, the metric system was improved at the General Conference of Weights and Measures to create a new system called the International System of Units, or SI, which is short for System International in French. The SI unit pertains to 7 fundamental scientific quantities. They are length, measured as meter, mass measured as kilogram, time measured as second, electric current measured as ampere, thermodynamic temperature measured as Kelvin, amount of substance measured as mole, and luminous intensity measured as candela. Let's look at each quantity one by one. The SI base unit of length is meter. Meter is the length of the path travelled by light. In vacuum, during a time interval of 1/2997/92458 of a second. The SI base unit of mass is kilogram, which is equal to 2.2 pounds. As per the SI unit, kilogram is the mass of a specific cylinder of platinum-iridium alloy kept at the International Bureau of Weights and Measures in France. Thus, it can be defined as the mass of the international prototype of the kilogram. The SI base unit of time is second. It is based on the radiation from the cesium-133 atom and is defined as the duration of 9192631770 periods of the radiation, corresponding to the transition between two hyperfine levels of the ground state of the cesium-133 atom. The SI base unit of electric current is ampere. It is named after André-Marie Ampère, a physicist who discovered electromagnetism. It is defined as the constant current which will produce an attractive force of 2 × 10⁻⁻⁷ Newton per meter of length between two straight, parallel conductors of infinite length and negligible circular cross-section placed 1 meter apart in a vacuum. The SI base unit of thermodynamic temperature is Kelvin. It is the fraction of 1/273.16 of the thermodynamic temperature of triple point of water. The SI base unit to measure the amount of substance is mole. Mole is the amount of substance which contains as many elementary entities as there are in 12 grams of carbon. Elementary entities may be atoms, molecules, ions, or electrons. The seventh unit on the SI base unit is candela. Candela is the luminous intensity in a given direction of a source that emits monochromatic radiation of frequency 540 multiplied by 10⁻⁻12 Hz and has a radiant intensity in that direction of 1/683 watt per steradian. Now, let's look in detail at some common quantitative measurements that we will come across in our modules. These are mass, volume, density, and temperature. Think about it. Is mass the same as weight? Oftentimes, people consider mass and weight to be the same things. However, that is not the case. Mass is the amount of matter present in a substance, while weight is the gravitational force exerted on a substance. This implies that the mass of a substance remains constant, whereas its weight may differ from one place to another due to change in the gravitational force. For example, a person's mass is 120 kg on Earth and the calculated weight is 1,200 200 Newton. If you weigh the same person on the moon, his mass would be the same, while the weight would differ. In this case, 200 Newton. This is because the gravitational force of Earth and Moon differ. Mass can be accurately measured with the help of analytical balance. Now let's look at volume. The base SI unit of volume is cubic meter. Smaller units, such as cubic centimeters, are frequently used in chemistry. Another unit of volume that is commonly used is liter. 1 liter equals 1 cubic decimeter or 1000 cubic centimeter. Some of the common devices used to measure volume of liquids are the graduated cylinder, burette, and pipette. Density is the amount of mass per unit volume of the substance and can be illustrated as shown in the equation. As this unit is large, chemists often express density in grams per cubic centimeter. Finally, let's look at temperature. There are 3 scales used to measure temperature: degree Celsius, degree Fahrenheit, and Kelvin. The Celsius scale is the most common unit for temperature, and we learnt that the SI unit for temperature is Kelvin. So, let's see how the 2 scales are related. The Celsius and Kelvin scales are divided into 100 equal parts. 0 degree Celsius is equal to 273 Kelvin. Thus, we can say that the temperature in Kelvin equals temperature in Celsius plus 273. Note that, unlike Celsius and Fahrenheit, temperature in Kelvin is not referred to as a degree. Now, let's see how the Fahrenheit scale relates to the Celsius scale. The Celsius scale is divided into 100 parts, while the Fahrenheit scale is divided into 180 parts. The freezing point of water on the Celsius scale is 0 degrees, while on the Fahrenheit scale it is 32 degrees. So, 100 Celsius degree equals 180 Fahrenheit degrees, or 5 Celsius degrees equals 9 Fahrenheit degrees.